Thank you for the introduction, Rodrigo. Like Rodrigo said, I will try to look into the future of extractables and leachables testing. Of course, this is my own opinion. It's my personal opinion. The only thing that I can say is it is based upon logic will prevail. You know, at a certain moment, things will come in order, things will become clear, but at this moment, we're still struggling with a lot of things. It's also the result of having discussions with a lot of people, having quite some mileage in the industry, having quite some mileage in extractables and leachables testing. I refer to Dennis, he's my partner in crime from time to time. I throw ideas at him to see if I make sense of it or not. Normally he comes back with a lot of criticism, but anyway, somewhere we find each other always somewhere in the middle. So the presentation will be about how will the science potentially evolve for extractables and leachable studies, and why do I think it could go in this direction. So first of all, it's about harmonization. I think there's a clear call within the industry to make sure that the methods and outcome of those kinds of studies are harmonized. We'll touch upon the AET. Dennis has touched upon the AET as well. We will have a look at identifications and what is really necessary there to guarantee a good outcome of an identification study, something that Ward has addressed already as well. Then quantifications, Dennis revealed already, let's say, the story at the end. So we want to be protective when we quantify. Maybe it is less of an analytical exercise of being accurate, but how can we become more protective? And then there is a trend across different industries to do research via non-targeted analysis. Non-targeted analysis is something, you know, an analysis where you do not know upfront what you're looking for, which is quite obvious in the case of extractable studies, but also in other industries. This is a kind of analytical practice that has been introduced, and there is a consortium that brings together that information, and the question is, how can we make use of that, or how would regulators over time see the value in what other practitioners with non-targeted analysis have come across. Let me start with the introduction. We are now in the third year of implementation of the ISO 10993-18. And in those 3 years, I think all practitioners, as well as the authorities, have learned a lot on how to design a study, on how to execute a study, and how to do the interpretation and reporting. Unfortunately, or fortunately, or actually it was a fact, was that there was a round-robin test that was performed right before the release of the standard. And that showed that when you send a device or a material to 5 or 6 different labs, the results of that analysis are scattered all over the place, whether it is the number of peaks, the identification of the compounds, or the quantification of the compounds. It was scattered all over the place. So as a result, regulators were not really very comfortable with making the step from, let's say, the traditional biocompatibility analysis to chemical analysis, because you don't know what you would expect. Did that lab do a good job or not? That means that they got into a certain cramp, and that is reflected in what you see as feedback from submissions or deficiencies, that they put the bar quite high to make sure that that doesn't happen in those kinds of cases. What we also see is that what was historically acceptable is at this moment is not acceptable anymore. So there's some kind of regulatory creep going on where we say, where will it end? And I think, like I said, I think that logic at the end will prevail. And we see that also with the TSL, with the toxicological screening limit. That is going up, and there's a clear reason why it's going up. So, but what could that, for instance, also mean for chemical analysis? Some of the observations. So in those 3 years that we have been doing extractables and leachable testing on medical devices, we have seen that there's a lack of trust with the authorities in the data of extractable data generated on extracts of devices. Also, we see an increasing scrutiny. So it's like, it's never enough. It goes further and further, whether it is identification, whether it is quantification, whether it is, triplicate testing, or what kind of extracts do you need to analyze. It's like it's never enough. There's also some kind of lack of understanding of some of the basic concepts, both with the E&L labs or the practitioners of extractables and leachable studies, as well as with the regulators. Let me give you one example, for extractable and leachable labs performing these kinds of testing. How you come to an identification is really not always very obvious. You have labs simply reporting the highest hit when you do a matching with a library like a NIST or Wiley, while others do intensive structural elucidation testing. For regulators, for instance, one of the cases that we have seen is that we were challenged because we used an internal standard. It is quite common. Let's say it's normal practice to use an internal standard for chromatographic analysis, because otherwise you don't know what is going on with your extract. I mean, these are the things that we're fighting against at this moment. There's also a lack of clear, of actionable and achievable guidance that sometimes leads to unrealistic expectations. It has been mentioned by Dennis. We have been asked to establish calibration curves, for instance, for all extracts. That is simply impossible. Or let's say the extremely low levels of the AET. That is sometimes you're looking in the noise to look, for compounds. That is simply not possible. These expectations are way too high. Sometimes the adherence to theoretical concepts we're struggling against. And here I'm referring, for instance, what kind of detector you should use. I understand, for instance, that some of these authorities want to harmonize because there's a lack of trust. If you send it to one lab, you get this result, send it to the other, you get another result, so that you try to harmonize also across detectors. But that's the selection of those detectors is often based on theoretical concepts that do not represent the true value of a detector. What I also have seen is that while the ISO 10993-18 is an extremely large step forward, is that there are still some unclarities that need to be addressed. We have talked about, the extracts. When do you disregard an extract, and how you proceed later on? For instance, that is one of the things that the industry is still struggling with. Sometimes we refer to the USP 1663 when it's about identification. But there also, I mean, although that guidance is quite good in defining the different classes of identification, it's sometimes, you know, it doesn't avoid malpractices. So there is also a clear need to fine-tune that guidance. When it comes to quantitation, often there is a referral to the USP 1664, which deals with leachables in pharmaceutical applications. But that is specific for leachables, for pharmaceutical applications. So how do you translate that into a medical device world? That is also something that is not clear. You know, in medical devices, typically it stops with an extraction study. While for pharmaceutical applications, you first do an extraction study and then do a leachable study on the drug product. And these approaches are simply a little bit different. Some new developments we observe is, for instance, what Sherry has presented is the new ISO 10993 Part 17 that deals about the toxicological assessments of the chemical analysis. There I want to refer to the toxicological screening limit, which really makes sense from a toxicological point of view, but where does it leave us, you know, looking into the grass with the AET? You know, these are all things, you know, that are not clear to me, how you can sustain these kinds of differences in approaches. And last but not least, the knowledge that has been acquired by doing non-targeted analysis across different industries. What can we learn from that? So a first thing is to build trust. I think building trust, making sure that regulators feel comfortable when they get a report, that if it would have been sent to another lab, that you get the same result. And that is, at this moment, we're not there yet. So the question is, how could we get to that point that you feel comfortable as a regulator, that wherever you send it to, it will be more or less comparable? It is, at this moment, very difficult to harmonize based upon methodologies. The reason why is that most of those labs have already developed their own strategy, their own testing strategy, have purchased their own equipment, have developed their methods and so on. It's difficult now to come and say, okay, you have to use this method with these system suitability test or whatever. Because that, you know, that is so impactful that you will need to change the whole knowledge base that you have built using your own methodologies. So that is not a possibility. What is a possibility is that you harmonize on outcome, so that regardless of which instrumentation, which methodologies that you're using, that the outcome would be the same. Some guidance would be practical there. If you're developing an orthogonal and complementary testing strategy, that you would focus on the same type of compounds that you need to be able to detect. And here, for instance, I would like to refer to a study that has been done in the environmental world. It was also some kind of round-robin testing, where they had, I think, 1,200 pollutants, and it was, like I said, a round-robin. It sent it to different labs, and they saw that 66% of those compounds were detected with GCMS. So that's a good place to start, because you're able to detect about 66% of those compounds. My gut feeling based upon what I see passing in our lab, is that it's more or less the same. That about 2/3 of the compounds will be detected with GCMS. So the question then becomes, what about the rest? What about the other third that you have not been able to detect with GCMS? How do you optimize your testing strategy to make sure that that 33% will be detected? What kind of detectors do you use? What kind of chromatography do you use? And so on and so forth. What has been addressed already, more or less, is the minimal sensitivity, because it has become clear that the LOD of a method, the limit of detection, should be lower than the analytical evaluation threshold. However, there we have the challenge that the analytical evaluation threshold is sometimes so low that you need to do things that may be impactful on the extract just to obtain the AET level. When we are thinking of harmonizing the output, we need to think of the users. And the users, who are they? These are typical toxicologists. So when you provide a report to a toxicologist, it should be clear. It should be, people should not need to be further interpret what is in the report. And let's start with identifications. If you put a name and CAS number and so on and so forth and a structure in a report, it better rewrite, because there will not be a toxicologist who will challenge that structure and say, okay, I think you have the wrong structure here. And from that perspective, if it is scrap in, it is scrap out. So there's no way of correcting any wrong identification anymore. Quantification is a little bit different. There, and Dennis has introduced that concept, maybe we should think of moving away from being accurate to being protective. Protective means that at least it should be the concentration that you see in your extract that you are reporting. You should also provide some other information in your report, like recovery yields, if you did a liquid-liquid extraction or you did a concentration step, and explain all the calculations that you have done, how you come to the dose-based threshold, how do you do the calculation for the AET, what kind of uncertainty factor that you're using, how did you do the calculation of your uncertainty factor, and so on and so forth. So the ultimate goal in the harmonization, what I think should be done, is that regardless of the methodologies and the instrumentation that is used, all labs should come up with the same number of compounds, the same identification, making sure that there are no conflicting information in terms of identification, and that the reported concentrations should be equally protective. They should not be equally accurate, because that is something that we're not after. They should be equally protective. For the AET, which is the cornerstone in the extractable and leachable assessment, it defines how low you need to go. There are some thoughts. So initially, when the concept of the AET was introduced by the PQRI working team, who wrote the recommendations for OINDPs, it was a concentration-based threshold. But slowly, we went to a response-based threshold. Now, when you're combining different methodologies, we know that the detectors are not universal, in a way that different compounds will have a different reaction or give a different response to each of the detectors. So that's why you have, because of that variation, you need to introduce uncertainty factors. Now, going to the other side of the spectrum, suppose that everything would have been determined from a quantitative perspective with validated methods. That removes the need of any uncertainty factor because you have done the validation. There's no uncertainty, there's no remaining uncertainty anymore because you're not doing non-targeted analysis anymore, you're doing a targeted analysis. But what about semi-quantitative analysis? That's somewhere in between. So you're sufficiently quantitative to give, within a certain range, to give a concentration, but still, would you need to apply a certain uncertainty factor or not? So this is also something that Dennis has introduced. Suppose that you would be able to correct every response with an associated relative response factor. That would mean that the response would be converted into a concentration, which is, from our perspective, semi-quantitative. But what do you do with those other compounds where you do not have RRF values for? There you could say, okay, we will introduce like a default RRF value with including the uncertainty factor of the statistics of your database. And that's the formula, that's the mean of the RRF of the population divided by the uncertainty factor. That is okay, but you don't need to bring your AET level down anymore then, because otherwise you do it twice. You bring your AET level down with an uncertainty factor, and you would bring your concentrations up with an uncertainty factor, which is double dipping. You know, it is correcting twice, so that is not necessary anymore. We have done that exercise, and we're in the process of implementing that across all techniques at this moment, and we see that we can avoid false positives and negatives. Another thing is going back to the toxicological screening limit. This is a table that explains a little bit where those limits are for different durations of exposure. For less than 24 hours, you have 120 micrograms per person. For 24 to 30 days, 240, and it continues until you have an exposure of higher than 10 years, and there you have a value of 5,000, rounded 5,500 micrograms per person. However, we use the DBT to calculate our AET levels, and you can see the difference. You can see the difference in where a toxicologist will take some action and what we need to provide in terms of information from when onwards. Although I can understand that the AET really needs to be lower, factor 10, factor 100, whatever. There are reasons to go lower. Cohorts of concern can be a reason. Grouping of compounds to do a tox assessment can also be a reason. But having this kind of divide between a toxicological screening limit and the AET is not sustainable. Something will need to develop, something will change, most probably, to bring that AET level up so that it becomes manageable. Or, however, the ISO 1093-17 is in its FDIS phase. Normally, content-wise, nothing will change anymore. It was introduced by the FDA, so you would expect that they accept it. So something is not right there. Coming to identifications, there's clearly a need for better guidance. There are two different challenges. For GCMS, it's more that some compounds are identified too lightly. In a lot of cases, what we see happening from time to time is that the highest match of a hit list will be reported, which is not always the case. I mean, there are certainly compounds that will be identified correctly at that point. But for sure, if the hit is low and you take the first on the hit list, you will run into problems. It's a binary effect. What I mean with that, with an identification, it's either right or wrong. There's nothing in between. And if you want to provide the right information to a toxicologist, it better be right. For LCMS, the challenge is a little bit different. Here, it's a matter of identification, of being able to provide some information about the compound, because that you cannot rely on NIST or Wiley. You don't have any reliable commercial databases. They're now developing those databases, but still we know that it is really instrument dependent, it is vendor dependent, it is setting dependent, and so on. So I don't think that it will ever come to a point where it will be comparable with GCMS. When you look at the USP 1663 guidance on how to classify the identification of a compound, I think there's a very good guidance. The problem is that it's not always well practiced. There is a need for an additional class. For instance, the partially identified compounds, for instance, it's a phthalate, or if it is an aliphatic hydrocarbon, because toxicologists will already be able to do something with that. They may de-risk the compound because of the fact that it has been reported as an aliphatic hydrocarbon, for instance. But if you look at the whole classification system, I think this USP 1663 needs to re-evaluate, how you come to a certain classification. Also, the nomenclature, for instance, confident and confirmed, is so close to one another that I often see confusion between those two terms, either in discussions or in reports. Will an upgrade change that? Most probably not, because often it is how the standard is interpreted by the lab. What I think should be done is that you need to justify how you have come to a conclusion on the identity of a compound in a report. You have to show the mass spectra, maybe a mirror image with the database, or with a library, the NIST library, for instance, to show that it's good. You also can use other criteria that is in NIST and Wiley. For instance, Ward talked about the retention index, which avoids reporting crap already for a large part, or reverse match factors, or fragmentation assignment, and so on. I think we need to upgrade the way we report identifications. For LCMS, I think it is a good idea to look first at the results of GCMS to see if there's any correlation between what you see in a mass spectrum on LCMS and try to link that to what you have seen in GCMS as well. Now, quantifications for non-targeted analysis. When we look at the feedback of regulators in general, the expectations are high and often unrealistic. I will sum up some of the feedback in the form of deficiencies that we have seen passing by. You need to use 3 surrogates for GCMS and 5 surrogates for LCMS. Use 5-point calibration curves to quantify all your compounds. If you're using RRF values, so relative response factors, they need to be based on 5-point calibration. Don't use internal standards because it could mask the presence of other compounds. This is setting the bar high. It is, like Dennis said, practically impossible to have calibration curves for a universe of well over 10,000 compounds, because we have 10,000 compounds in our database already. So, and we know that we are not there yet. So it's practically impossible to have calibration curves for 10,000 compounds. Even if you would do that, how do you maintain the calibrated state? You know, it's simply not possible. So the strange thing is that it is known to the FDA, only not to the CDRH branch of the FDA. On the right-hand side, I have put an article which has been published by the the food department of the FDA, where they also do non-targeted analysis, and they compare different approaches and the accuracy of the different approaches. And as you can see, you know, of course, the gold standard is calibration, and that's what you see here on the left-hand side in the figure. The right-hand side is what CDRH is promoting, is using surrogate standards. You need to use 3 or 5 or whatever. But of course, how do you link the surrogate or the compound that you have detected to the right surrogate? So that is gives you, in that article, the largest uncertainty. Our approach is somewhere in the middle. And we know that. I mean, we claim that it's semi-quantitative, and we're aware of that. You cannot compare it to a full calibration curve, but as long as it's protective, we think it's a good approach. So the question is, you know, when will that awareness spill over to CDRH? There is a lot of literature, you know, about non-targeted analysis. Only, you know, at this moment, it is still something that needs to be implemented. There needs to be some kind of awareness that a non-targeted analysis has different criteria than a targeted analysis. That is also reflected in, let's say, the expectation of extraction yields, for instance, where they want to see between 85 and 150%, while in environmental analysis, it's like Dennis said, it's between 50 and 200. It's divided by 2 or times 2. So there's also some kind of gap in the expectation on what you can provide compared to what is requested. Looking into the future, high accuracy and non-targeted analysis are terms that are really incompatible. Of course, you want to avoid second pass testing as much as possible. Suppose that you see 30 compounds, that you need to calibrate all 30 compounds. That's something you want to avoid. So what can you do to avoid that, to avoid the frustration of having to do too much work without any added value? And that's where the term being protective comes in. If you can generate a concentration that is protective rather than accurate, and that would be accepted, that would mean less work, but would have sufficient value to go into a toxicological risk assessment. Of course, those correction factors to go from responses to concentrations would need to include some kind of uncertainty factor, of course. And that would be based upon the statistics of your database, for instance. The question is, how much coverage would you have? You know, if you apply an uncertainty factor of 2 and 5 for GCMS and LCMS, how much compounds would fall within that bracket that the responses would be protective with that uncertainty factor? And that is something you can easily calculate if you have a database. Now, some concepts on the non-targeted analysis and what can we learn from that. For people who would be interested in non-targeted analysis and publications that have been sent out recently, I would propose to go to the website of the BP4 NTA, so Benchmarking and Publications for Non-Targeted Analysis. It's some kind of consortium that has been set up across different industries, so environmental testing, food testing, forensic testing, cosmetic, chemical, medical, and pharmaceutical. And the question is, what can we learn from one another? Because it is a new practice. It's relatively new in a way that the instrumentation that is now available allows us to do that, which was not the case before. And they also give some guidance. They give some guidance in how to develop certain protocols, how to do the interpretation, how to avoid false positives and negatives, for instance. So I think over time, information of this application will spill over into the regulations of how to test for extractables and leachables as well. One of the things that was striking to me when I read that was they define different ways of doing your non-targeted analysis. They have the suspect screening analysis, and that is the identification by comparison of a predefined user list. And it is guided by prior knowledge. So this is exactly what we're doing with our database. So the prior knowledge is that we have encountered all those compounds in materials on which we have performed an extraction study already. So all those 10,000 compounds are relevant because we have seen them. So this is actually what we do with the database. We do suspect screening. Of course, we combine that with non-targeted analysis, and that's where you do not have any information whatsoever what it could be. And then we need to rely on other sources like NIST or Wiley with a good evaluation of how the fit of the mass spectrum of the compound that you have encountered, how does it fit with the entries in the database. I will skip this one, but other guidance that you will see on the website of the BP4 NTA or how to set up an NTA study, a non-target analysis study, how to perform annotation and identification, so we can tap into that information if we want to upgrade the way identifications are reported. Differentiating databases from libraries, and also there's a confusion matrix where there's an evaluation of the methodology in terms of what number of true positives do you have, how many false positives you have, how many false negatives you have, and how many true negatives you have. So this could become some kind of criterion if you do an evaluation of your screening method. Last but not least, it also contains a non-targeted analysis reporting tool. And what I think is that also some of those concepts that are described also in an article that has been published recently by Georgi Vass and collaborators could spill over into the requirements or expectations of how to report extractables for medical devices. As a conclusion, extractables and leachable testing for medical devices is gaining maturity, but we're not there yet. However, some basic concepts are still not always very well understood, both from the practitioner side as well from the authority side. There's a call on harmonization on the outcome, making sure that when you send a device out to a different lab, that you get the same outcome. There we need to focus on the way identifications are performed and also move away from, when it comes to quantitation, from being accurate to more being protective. And I would say there's a whole new era of non-targeted analysis and information supporting that is becoming available. I would say this will be also a great resource to have that included into the new regulations. And with this, I would like to thank you